Okay, today we're looking at the first part of our new unit, which is on linear relations, and the first big idea, which is that we can use a linear equation to describe a pattern and then use the equation to solve problems. First of all, let's just talk about this word relation or relationship. In mathematics, relationship is when two numbers or two variables are related to each other. Let me give you an example of cars and wheels. So if we have a number of cars and how many wheels there are, if there's one car there are 4 wheels, if there are 2 cars there are 8 wheels, if there are 3 cars there are 12 wheels. So we can see that there's a constant relationship between the number of cars and the number of wheels, that it's always the number of cars times 4. So if we were going to say that the number of wheels is equal to, we could write that as a linear equation. It would look like the number of wheels is equal to 4 times the number of cars. Whenever we write a number beside a variable, that means we're multiplying. We don't have to use that x anymore to mean multiplication, because we might want to use x to represent a variable. So anytime there is a number that's right beside a variable, it means we're multiplying. So here we are. That first big idea is that we can use a linear equation, which is this one here, that the number of wheels is equal to 4 times the number of cars. We can use that equation to describe the pattern that we see over here, and we can also use that to solve problems. Here, I'll give you a problem. Let's say there are 10 cars. How many wheels are there? Well, I can just take my formula or my equation and say if cars is equal to 10, then this would become 4 times 10. I'm using brackets to show multiplication now. So the number of wheels would be equal to 4 times 10, which is 40. So that's a very simple relationship, but it does give you an idea of what we're talking about. When we're talking about linear relations, it means that that relationship is constant. It does not change. It stays at that same rate. Wheels is equal to 4 times the number of cars. We can also graph that. So to graph that relationship, remember the relationship is W is equal to 4 times C. We simply use our Cartesian coordinate system with the X and the Y. And we're going to look at the points that we identified before. So the points are simply some of the data that goes with this equation. If I make a little table of values over here, just to remember again, W and C. When C is 1, W is 4. When C is 2, W is 8. So these become points on the on this coordinate system. So the first one is 4, 1. So we're going to look at 1, 2, 3, 4. 1, 2, 3, 4. I didn't do this too accurately, but there's 4, but it's not 4, it's 4, 1. So 4, 1 is, let me just get rid of that one. So let's pretend that I've drawn this more accurately and that that's right on the line. So that would be 1, 2, 3, 4, and 1 is there. And the next point is 8 and 2, so we're going to go out to 1, 2, 3, 4, 5, 6, 7, 8, and 2. And the next point would be 3 cars, would be 12. 8, 9, 10, 11, 12 is at 3. And we can draw a line connecting those, and it's a straight line. That's where we get this idea of linear relationship, because it's a line. So the graph gives us a straight line. And the graph in this case does not, I mean, we could draw it right from 0, because I suppose if there are 0 cars, there are no wheels. And then the first, at the first number of cars there. So the y is equal to the number of cars, and the x is, in this case, is the number of wheels. Just the way that we draw it. And that should appear like a straight line. So going back to our big idea, we can use a linear equation to describe a pattern, and the pattern is the wheels of the cars, and then we use that linear equation, we can draw a graph of it, and we can use it to solve problems.